Hello students, let us continue the session on revision in the chapter surface area and volume. Question number 10 is 500 persons are taking a dip into a cuboidal pond which is 80 meter long, 50 meter broad. What is the rise of water level in the pond if the average displacement of the water by a person is 0.04 meter cube? Here we are not known about the height of the water. Let the water displaced I'll consider as some height x meters. So here the volume of water raised will be same as the volume of cuboid. Here volume of the cuboid is length into breadth into height. It is 80 meters into 50 meters into x meters. Volume of the water raised is by 500 people. So 500 persons has to be multiplied with 0.04 meter cube. Now I need value of x. X will be equal to 500 into 0.04 divided by 80 into 50. 80 into 50 is 4000. On further simplification, we get it as 0.5 in terms of centimeter, because we get 1 by 200. This 50 and 50 I can cancel it out. I'll be getting 1 by 200 meter. This is same as 1 by 200 meter. So the raise in the water level is only 0.5 centimeters. Question 11. 16 glass spheres, each of radius 2 centimeters, are packed into a cuboidal box of internal dimensions 16 centimeter into 8 centimeter into 8 centimeter, and then the box is filled with water. Find the volume of the water filled in the box. Here they have given that the length, breadth and the height of the cuboidal box, and also the radius of the 16 glass spheres. Here in this scenario, the volume of water filled in the box will be equal to the volume of the box minus the volume of 16 glass spheres. The reason is the remaining space will be filled with the water, so the remaining space is the volume of box minus the volume of 16 spheres. Volume of the box is given by LBH and 16 times 4 by 3 pi r cube. Now length is 16, breadth is 8, height is 8 minus 16 times 4 divided by 3 multiplied to pi value 22 by 7, and the radius cube is 2 multiplied 3 number of times. Here observe there are certain things common. Let me highlight that 16 is common, 8 is common. Here 16 and 2 4s are 8. This I'll take as a common thing. So 16 into 8 is taken common. What remains is Here 8 remains minus 22 upon 3 into 7 into, here 2 into 2, 4 will remain. I need to take the LCM. The LCM will be 21. So 16 into 8 multiplied to 21 times 8 minus 88 divided by 21. This will be 168 minus 88. That gives us 80. So it is 16 times 8 times 80 upon 21, and the approximate value is 487.6 centimeter cube. This will be the volume of the water filled in the remaining space of the box. Question 12. One of your friend was asking a doubt that this frustum is not there for syllabus, then why are you teaching this particular concept? Let me remind you, these are little important concepts. If you are going for any competitive examination, you may be asked about this, so you need to remember the formula and all. So this may not be helpful for this year's examination, however, this is an important concept. A milk container of height 16 centimeter is made of metal sheet in the form of frustum of a cone with the radii of its lower and upper ends as 8 centimeter and 20 centimeter respectively. Find the cost of the milk at the rate of rupees 22 per liter, which the container can hold. So here it's a direct question of finding volume. Let me write the lower base radius with the letter R1. It is 8 centimeter. The upper radius is R2, 20 centimeter, and the height is given. The height of the frustum of cone is 16 centimeter. So the volume of milk is same as the volume of frustum. Is 1 by 3 pi h times R1 square plus R2 square plus R1 R2. This particular formula you must remember. So 1 by 3 to be multiplied by 22 upon 7 into the height is 16 times R1 square is 8 square, R2 square is 20 square, R1 R2 is 8 times 20. Let's simplify this. We'll be getting 22 into 16 divided by 21 multiplied to, see, 8 square is 64, 20 square is 400, plus 8 times 20 is 160. So we get 22 times 16 is 352 divided by 21 into 64 added to 400 added to 160 is 624. So on further simplification, you'll be getting 10.459 liters. Therefore, the cost will be 10.459 to be multiplied by 22. Approximate value I'll be writing here. You can cross check, 230.107 rupees. Question 13. A cylindrical bucket of height 32 centimeter and the base radius 18 centimeter is filled with sand. This bucket is emptied on the ground. A conical heap of sand is formed. If the height of the conical heap is a 24 centimeter, find the radius and the slant height of the heap. So for the radius, I'll consider small letter r and slant height as L. This has to be found, and the height is given as 24 centimeter, that is for a cone. And one more, cylindrical bucket, I'll consider capital R as the radius, it's 18 centimeter, and the height is 32 centimeter. These are the given things. When I have written small h here, let me mention this as capital letter H. So here, volume of conical heap will be equal to volume of cylinder. Volume of the conical heap is 1 by 3 pi r square h, which will be pi r square h. For the cylinder, capital R and capital H are taken. Here, pi will get cancelled. We require radius here, so r square will be equal to 3 times capital R square into capital H divided by small h. Let's substitute 3 times r square is 18 square, which is 18 times 18 into the height is 32 divided by the height of the cone, which is 24. Here 3 8 times, 8 4 times, so further it is 18 multiplied to 18 multiplied to 4. On taking the square root, I'll be getting 36 centimeter. Now radius is found. Now we need slant height. We know that slant height of a cone is given by root of r square plus h square. So it is root of r square is 36 square plus h square is 24 square. Further, you can try simplifying this. I'll write the direct answer 12 root 13 centimeter. On finding the value of root 13, it is 3 point something. 3.5 is 10 point some 10.5. So it is 3.61 approximately. So 12 times 3.61, it's approximation. We get approximated slant height as 43.27 centimeter. So 43.27 centimeter is slant height and the radius is 36. Question 14. A rocket is in the form of a right circular cylinder closed at the lower end and surmounted by a cone with the same radius as that of the cylinder. The diameter and height of the cylinder are 6 centimeter and 12 centimeter respectively. If the slant height of the conical portion is 5 centimeter, find the total surface area and the volume of the rocket. It would look like this. It is a cylinder on that a cone is surmounted. When I draw rough figure, it doesn't look proper, but then you need to adjust. The height of the cylindrical portion is 12. Since the diameter given is 6, I have taken radius as 3. The slant height is given as 5. So all the information is known to us. Do we know the height of the cone? Height of the cone is not known to us, that we need to find. H will be a root of L square minus R square. L square is 5 square minus 3 square, 25 minus 9 is 16. So we get it as 4 centimeter. This is the height of cone for cone. Now, let me first find out the volume. Volume of a rocket will be volume of cylinder plus volume of cone. Volume of the cylinder is given by pi r square. I'll take capital H as the height of the cylindrical portion. This is capital H. Plus volume of the cone is given by 1 by 3 pi r square h. If you observe, the radius of both these cone and the cylinder are same, so I can take pi r square as common and the rest of the things as h plus 1 by 3h. They have given 3.14 to be used as the value of pi. It should be multiplied with 3 square, which is 3 times 3. Capital H is 12 plus 1/3 of small h. Small h is 4. So this has to be simplified. It is 3.14 into 9 into, this will be 4 by 3. 36 plus 4 is 40 by 3. 3 times. So it is 3.14 into 120. We get 376.8 centimeter cube. This is the volume of the rocket. They have asked us to find the total surface area also. How do we find the total surface area of the rocket? It is the curved surface area of cylinder plus the curved surface area of cone plus base of cylinder. Remember friends, here only one of the base has to be considered, not both the base, because one of the base is embedded inside. Only one of the base, which is downside, to be considered. The cylinder's curved surface area is 2 pi RH plus the cone's surface area is pi RL plus base is pi r square. Here pi r is being common. I'll write 2 times h plus L plus r. Directly substitute 3.14 multiplied to the radius is 3 times of 2 into 12 is the height of the cylinder plus the slant height is 5 plus the radius is 3. This will be 8 added to 24, which is 32. So 3.14 to be multiplied with 3 to be multiplied with 32. This will be equal to 301.44 centimeter square. With this question, I'll end today's session. Some more questions will be solved in the next session. Thank you.